Okay, today we're going to do 1.2, which is angles of elevation and depression. You may have done this before. We're going to be trying to always find a right angled triangle in this case so that we can use our ratios, sine, cos, and tan. Now, an elevation angle is looking up. Now that means if this is your eye, it's a dodgy eye, but anyway, if that's your eye, there's some eyelashes, the angle of elevation is from your horizontal sight, so where you would just be looking straight ahead, up to if you were looking at a plane in the sky. There's my plane. Okay, this is the angle of elevation, as you can see here. Sometimes we assume that your height is but a dot. All right, no funny jokes about short people, but if you're not given a height, you assume it's a dot. Now, depression is a bit more tricky, okay? Depression is when you are down, and that is the angle if you are looking straight ahead to where you are looking down. So this is the angle of depression here. Okay, lots of people get confused and think that it's this one, all right, but it's not. It's from the horizontal down. So just be really careful. Once again, sometimes we assume that we are zero height. Now, here are the steps that I would like you to go through with these problem-solving ones. I want you to always sketch a diagram. I want you to put in a right-angled triangle, if you can, and label all the sides. And then I want you to identify what is given and what needs to be found. I want you to select the right ratio and then use it and interpret your result, please, by writing an answer in a sentence, okay? Now, I've just got a little trick down here. If you've got an angle of depression, say we're looking from a hill down to a boat, okay, this is the angle of depression here. Sometimes it's really useful to actually put in what we call an alternate angle, and you would have done these probably in earlier maths, the Z rule sometimes we call it, okay? If these two lines are parallel, which they will be if they're horizontal, then that angle and that angle are equal, but only if these lines are parallel. Okay, so sometimes we put the angle of depression in the triangle here, which makes it a bit easier. All right? Okay, let's have a look at some examples. Find the height of a vertical cliff if the angle of elevation is 25 to the top from a point which is 235 meters from the base of the cliff. All right, so I draw a diagram. Here's my cliff, and I am standing 235 meters from the base of the cliff. That's the base of the cliff. And I'm looking up at the top. I haven't been given a height, so I'm assuming zero height. Assume zero height. You need to write your assumptions. Okay. Find the height of the vertical cliff if the angle of elevation is 25. So here I am, here's my eye, there's the horizontal, there's me looking up at the top. What do I need to find? Let's call it X. That's what I need to find. So this is the opposite side, and this is the adjacent. That is the tan ratio. I always want to see your rule written, please. Okay. Then I want you to put your numbers in. 25. Opposite is X. Adjacent is 235. And now we use algebra. Because that's a divided by 235, I'm going to multiply by 235 on both sides of the equation. And this I'm now going to do on my calculator. All right, make sure that your calculator is in degrees because you're working with degrees. So 235 multiplied by the tan of 25 equals 109.58 meters. Okay, and I'm going to write it in a sentence. Does it seem reasonable? You should always ask yourself that. Yeah, that doesn't seem too unreasonable if this is 235 meters from the base. The height of the cliff is 109.58 meters. Okay? All right, let's do an example of depression. From the top of a vertical cliff, okay, so here's my cliff, and I'm at the top, 75 meters above sea level. Okay, so this is the sea, so I better put some waves. The angle of depression of a boat straight out to sea is 20 degrees. Now, once again, we assume zero height because we haven't been told how tall the boat is. Assume zero height. Okay. Now, the angle of depression is where I would normally be looking out straight down to where I'm looking. So that's actually 20 degrees. But remember, because we're assuming that the ocean is horizontal, then that's going to be 20 degrees in there. Okay. What do I need to know? How far is the boat from the base of the cliff? So that's what I need to know. Okay. Now this one, that's the opposite side, and this is the adjacent, which is tan again. Always write your rule. Now this one's a little bit trickier because when I put my numbers in, I actually end up with the x on the bottom. All right, so this is a two-step process. I have to multiply by x on both sides. Oops, sorry. And then I have to divide by 1020. Some people do a bit of a shortcut and miss this step out, go straight from here to here. That's okay, I don't mind it. Some people just remember that you swap those two. Okay, as long as you understand the reasoning behind it. And now I go 75 divided by 10 of 20. And that gives me 206.06 meters. Does that seem pretty reasonable? Well, that's a fairly small angle, 20 degrees, so you would have to be a fair way back, wouldn't you, for it to be a small angle. The closer you are, the bigger that angle is going to be, so that probably does make sense. The boat is 206.06 meters from the base of the cliff. Okay? All right, and I'll just, don't think we need to do those. Those just a repeat, I don't know why. And now you can do exercise 4D, please.